Hello everyone, this is our project Robokeeper, where we built an automated goalkeeper which uses two cameras, and these two cameras instruct our motor to move a specific angle to try its best to save the goal.
So yeah, getting more into how our actual system works, we have two pixie cameras here that are meant to detect this yellow ball. So how the pixie cameras work is that there's an algorithm that is processed on board, and it just looks to find the color yellow, which is the color of our ball here. So yeah, so for example, if you start with this top pixie camera here, it's looking down towards this black paper, and because it's black, there's a lot of contrast with the yellow ball, so it's easy for it to see. So yes, so once this ball comes into the frame of this pixie camera, it sends a signal through I2C communication to our MCU to ask this pixie camera where it sees the ball. So then, with these two cameras, we're able to find to make a 3D coordinate plane with the ball's location. Then from there, we can pass it on to our stepper motor.
Within our MCU, once we get these coordinate systems, we instruct our stepper motor to move a specific angle using using a PWM signal, and then it tries its best to stop the ball from going inside. We obviously don't expect our keeper to save 100% of the time, so we also have a goal detection system. We're going to do a demo of how our Pixie camera works with our keeper right now. So as you can see, if I was to move the ball a bit slow towards the ground, it will go all the way flat. Then if I was to move the ball at a specific height, our stepper motor will move at a specific angle using, again, these XY coordinates from our two Pixie cams.
Yeah, then you may notice that down here, we reset our motor, so we disable its enable pin so that it falls to the ground and so we don't cause any damage to the motor.
Just to show it on the left side as well, we have, if I go on the ground, it will go all the way to the ground. And lastly, if I was to do it at a specific height, it will move a specific height.
So now I'll talk about a goal detection system, which is this contraption over here. So once the keeper fails to save the ball and the ball goes into this contraption, we have an RA distance sensor that will detect the presence of the ball. So then this distance sensor varies its voltage by the location of the ball, how far the ball is away from the sensor. So once that signal is received, we send it to our MCU through an ADC, then we convert it to a digital value. Then we check this digital value against a certain threshold, and once that threshold is exceeded, we call an interrupt. This interrupt will call all our other components, which are part of our goal display system, that are designed to display a certain goal.
So within our display system, whether us showing whether it's a goal or not, we first have an display, which displays which we interface through I2C communication. And within this I2C communication, we display the score.
Okay, the screen will function under the logic we programmed it. So under the game logic, right now we are using the MPU will send several commands to the screen so that it can display the content we want. So right now in the default mode, it will display how many scores you get. After you get a score, the RF sensor will send an interrupt to the MPU, and it will send the command to the screen so that a word goal will be displayed on the screen, and also the number of scores will increment by 1. There's also a button on the board. After you press it, it will send a different interrupt so that you can reset the scores and start the game all over again.
So continuing on with this goal detection system, we also have a speaker which plays out a goal sound every time a goal has been scored. As you can see right now in the default case, it's just playing a background soccer sound, trying to mimic how the crowd is in a real soccer match. So the way this is done is that we have a timer interrupt, which interrupts our program every 44.1 kilohertz. Within this interrupt, we index into a DAC array, and a specific part of the DAC value is played within our speaker. So for when a goal has been scored, a goal sound will be played, and then another timer interrupt will be played with that goal sound.
So yeah, now the last component of our goal detection system are these LEDs over here. So they both work on the same interrupt as the other systems here. So what happens is, once it receives the interrupt, it uses a PWM signal and DMA to flash these red lines here green. So as you can see, currently we have a base state where the LEDs are red, but as we detect the goal this side, we'll see that they turn to green and start flashing green. That should wrap up the entirety of the goal detection system. Then from now on, we'll just display a demo to show you how the entire system works. So yeah, so now I'll show you how our detection system works as a whole. So as you can see, if you listen closely here, we have ambient sound, which is meant to replicate how a real life stadium would sound. Then we also have our red LEDs here, which are red because nothing has been detected, and our display is just showing a score. So I'm gonna throw the ball in now. The keeper is turned off, so we're gonna score very easily, and you should see every part change.
Hello everyone. Now I'm gonna do a demo, which includes our pixie cam with our stepper motor, including our goal detection system as well. I'm gonna first throw a ground ball first of all. As you can see, it saved our ball quite good. I'm gonna do the same on the left hand side. Saved quite good as well. I'm now gonna throw it at a height to see how keeper saves it. You can see it saved quite good. As you can see, it's saving all the balls that it's thrown at it. Obviously, we don't expect our keeper, like we said, we don't expect our keeper to save 100% of the time because we're obviously limited by the sampling time that we have for our pixie cams. So if I were to throw very fast, we expect it to go in. So you can see the goal displayed. But yeah, that is our demo for us showing how our project works. Thank you very much.